this video, we'll discuss how to find the volume of a cone. Now, you probably remember from your previous math classes that a cone is simply a three-dimensional figure that has a circle for a base and an upper surface that narrows to a single point called the vertex. Now, as far as what the cone looks like in the anatomy of a cone, we really have a couple different heights going on within the cone. We have the actual height of the cone as itself, which is the distance between the vertex of the cone and the center of the base. And we've got the slant height of the cone, which kind of goes down the outside of the cone to any point on the edge of the base. If we're given slant height and we want to find height, we can use a little Pythagorean theorem due to the nature of the right triangle that's formed by the radius of the circle, the slant height of the cone, and the actual altitude itself of the cone. And vice versa. If we're given the height but we want to find the slant height, we can go back and forth between the two simply by using the Pythagorean theorem. All right, the formula for finding the volume of a cone is 1/3 times the area of the base times the height. Looks very familiar in that it's the exact same formula that we use for a pyramid. And if we go to the reference sheet for mathematics and look to find the volume or the formula for the volume of a cone on this reference sheet, and we look down through all the volume formulas that are given to us, we notice that we see a formula for the prism, for the cylinder, for the sphere, for the cone, and for the pyramid. So the one that we want to use is the formula for a cone. Notice that what's here on the formula sheet is a bit different than area of the base times the height. However, our base is a circular base, and the formula for the area of a circle is pi r squared. So although these formulas look different in their visual representation, they are in fact the same exact formula. So this one here, due to the nature of the circular base, they've replaced area of the base with the pi r squared. All right, so let's go ahead and jump into some examples. Number 1 says a circle has an area of 25 pi square inches. So I'm going to go ahead and draw a circle with an area of 25 pi. When we take and extend a point 12 inches straight down from the center of the circle, which means I'm going to go back and redraw my circle, because I want to draw that in such a way that I can go 12 inches down from the center of that circle, we get the right circular cone. So there's our cone. My picture's not very good, but it is going to be good enough to get the job done. Let me go back and tidy that up just a bit. So there's my cone. The area of this circle is 25 pi square inches. We want to go ahead and find its volume. So volume, formula from the formula sheet, volume is equal to 1/3 times pi times r squared times h. However, this guy in here is already our pi r squared. So within this formula, I'm going to replace the pi times r squared with 25 times pi. And then the height of our cone is exactly what they've given to us. We don't want the slant height. We don't want the distance down the outside, but we want the distance or the height inside the cone, and that's 12. And notice that they don't say to round this answer. So I'm simply going to get my calculator out, and within my calculator, I'm going to multiply the 1/3 times the 25 times the 12. And when I multiply the 1/3 times the 25 times the 12, my calculator tells me 100 times pi. And since I'm not told to round, I'm simply going to leave my volume in terms of pi. So this would be cubic inches. So a key idea here, you want to leave exact values meaning in terms of pi, unless you're told to round. And if you were asked to round this to the nearest tenth or the nearest integer or the nearest thousandth, you would get your calculator out and you would type in 100 and then the pi button on the calculator and round as you were directed. But again, you need to know that unless they tell you to round, we're going to leave everything in terms of pi. All right, the next one says we have this cone with a radius of 9 centimeters, and this cone has a volume of 675 pi cubic centimeters. They're asking us to find the height of the cone. Since we don't have a picture, I'm going to go ahead and draw one. I like to draw my cones by starting with a circle and then just attaching a little triangle. It's not a very sophisticated cone, but it gets the job done. This radius, 9 centimeters. And they don't tell us the height of this cone, but rather the height of this cone is what we're trying to find. So I might call the height h or x, however you want to label your variable. We do know that we're dealing with volume. And anytime we're dealing with volume, we want to start by writing down the formula for volume. In this case, I know my volume is 675 pi. So in place of the volume in the formula, I'm going to substitute volume for the 675 pi. The radius is 9 times the height, which is x. I'm going to go ahead and do order of operations and do my exponents first. And then because multiplication is commutative, I can multiply in any order that I want. I'm going to go ahead and multiply the 1/3 times the 81. And I'm still multiplying a pi times an x. What I want to do is I want to get x all by itself. So to undo multiplying by 27 pi, I'm going to divide both sides by 27 pi. When I do that, I'm left with x all by itself on the right side of my equation. And when I get my calculator out and type in 675 pi divided by 27 pi, I end up with 25. So I know that the height of my cone now is equal to 25 centimeters. As always, I don't want you to close up your notebook at this point, but rather I want you to flip up to the top of the next page. And I want you to think about what you've seen and in your own words, summarize the key ideas and the important takeaways from the video. And then see if you can go ahead and use your newfound knowledge to go answer the questions on page 13.